Hello, hello. How's everybody doing? I was rushing a bit to get everything set up here. I was coming out of one meeting and probably going into another meeting here, which actually reminds me. When are we going to? Okay, so we got a little bit of time today. We are looking at Rust Workspace inheritance today. What do you call it? Cargo inheritance? Workspace inheritance? Either way, Rustling. Pop on over here real quick. Within Rust, you can have a single crate, which is like the package. Cargo is the runner. A crate is the thing that's being run, I guess. And you can have a single crate, or you can have multiple crates, which then make it a workspace, which is not workspaces is basically multiple crates, and you can have that's then becomes the more generic term, I guess, would be mono repo. And then you start getting into even like you can pull in multiple languages. And if you've ever used a Tauri app, technically that's a monorepo, a polyglot monorepo. Polyglot meaning multiple languages, and monorepo being basically multiple repos within one repository. So with Rust, with the Rust or Cargo, I guess we should figure that out. The workspace inheritance, it allows you to specify some of the metadata at the root and inherit it in the crates downstream. So I think one of the things that when I was seeing it was you could specify the version in the root, and all the crates in that workspace would get it. So that would be one way to manage the versions of your crates. Would be to have, especially if these are crates that are very closely tied together, it could make sense to have a single version of the root and have every crate inherit that. But you can also do that with dependencies, I believe, too. But we're gonna kind of figure that out. It kind of went, this went under my radar, and it came out a couple of versions of Rust ago. We have big V. We have Cargo 1.68, and I think that also means that we have, is it Rust? Check the Rust version. I suppose I could just do Rust up, which is their officially supported way to install Rust and Cargo. Show Rust up show. I got a couple old ones kicking around here that I could probably get rid of, but the active toolchain right now is Rust C 1.68. I think Workspace Inheritance came out in 1.64. I believe I put it in the description. I wrote that the other day, and now I don't remember. Rust Workspace Inheritance. So either way, it kind of went completely under my radar, to be honest. And I want to make sure that we understand what we're working with. So we can do the workspace root is the directory where the workspace is Cargo.toml is located. We can put a version in there. It's also a virtual manifest. Okay. So this would be more for, there isn't a primary package, or you want to keep them all organized in separate directories. So you can kind of have a like real root package, then you can also just completely keep them separate. And then the root Cargo.toml is more of a helper metadata thing really than it is anything to do with the package itself. So very interesting. Why this came up was there is a package Tauri. It is Tauri. If I can spell today, oh my. Tauri Bindgen. I was chatting with Jonas the other day, and they set up this as a workspace, I guess, as a workspace with the inheritance. And I maintain a package that we originally wrote for Tauri, but it's starting to get used in other places as well. But primarily it was started because of Tauri, a package called covector, and this allows you to specify change files. Do I have any here? Yep. Which are markdown based with some front matter that specify what you want bumped, and rather than setting a version specifically to bump to, you can describe the type of change it is and what bump would be necessary for it. So patch, minor, major. And it also does alpha beta type stuff as well. There's other systems out there that are similar, and there's also conventional commits and what have you, but most of them don't have a way to deal with polyglot monorepos, which Tauri is very much so. So we went through the effort to spin this up. And this needs to know and be able to set the version. So if the location of where that version number has changed, then it doesn't work. So that's actually why this discussion came up, because I think package normally the root. Nope. We want fixtures. We look at one of our Rust. Setups here. Okay, so this would be a virtual manifest, I believe, if I'm understanding the terms correctly. Virtual manifest being, or virtual workspace. That is a virtual workspace. The one we were looking at is a virtual manifest. Where'd that go? Root. Yeah. So this is what we were looking at. And it does work with that. We can do virtual workspaces, and those I think have been around for some time, at least as long as I remember. And we then specify the version number in the package and the version. And if we look at this one, we've got Tauri Bindgen, and then we have crates. And each of these crates has its own Cargo.toml, of which it is using the version from the workspace. So this actually does not have a version number anywhere, which would be fine. It would work with this because we're not actually changing the version number here. And technically, it would be kind of nice to have like separate changelog for these potentially. Um, I think there's maybe a discussion to be had there. What is wit? Interesting. I'm unfamiliar with that. Do we do separate changelogs for this? So I guess the question is, when we're publishing this, is this publishing more than one crate? It is doing make release. So part of what's going on here is we are builds the release and creates an archive and option deploys to GitHub. Okay. So I think this is doing a lot of what we were doing with covector, because it's doing a cargo build. And it is just doing the Tauri bind gen, it looks like. We have a couple different operating systems that it's working on, and then it's using the GitHub CLI to reload those, upload those assets to the GitHub release page. Pull request push. Those are just helpers. So the release setup is, I guess we're not, are we only uploading it to GitHub releases? So we're not actually publishing these. Without this CLI, and before this helper and the CLI existed, this was so much more effort to deal with. I definitely really appreciate what they've done with the CLI as far as it's just, what's the word I'm looking for? Life. My goodness. It's just such an improvement. Wow, what's the word I'm looking for? Life improvement? No, whatever. It's fine. I like it. It's good. I appreciate it. So I think all that we really care about is, in this case, we kind of only have a root package, or a root crate. Cargo.toml. Wow. A root cargo.toml that we care about. And is that going to be consistent? Is this how this repository is set up? Or do we have more setups that we kind of care about here? So we have a few things that we can define. Keys for inheriting in packages. So we should support virtual manifests. Excuse me. In covector, that is. We have a workspace in the root. We would effectively just ignore this as far as covector is concerned. This was what we'd be operating on. It has its own version number, so like we care about it as a separate unit. It's fine if it inherits things from the workspace or whatnot, but it's that version number that's the real kicker. Members and excludes, which packages are members of the workspace. Okay. So we can use globs, but then we can exclude a or a member from that glob if we want to. So we can potentially have multiple workspaces. Interesting. And this does affect some of the cargo commands too, which I'm a little bit less familiar with. I know they exist, but remembering to use them and working within a large Rust monorepo is something that I'm less familiar with. I mean, despite I work with Tauri, these days a lot of what I do is administration type things. And prior to that, I was doing a lot of CI, docs, that type of thing. So I actually have not touched much Rust within Tauri. Ironic, because that's part of what part of why I was getting involved with Tauri is because I wanted to get Rust a little bit. So we've got, let's see, we got the package table. These are all the keys, which are pretty much the same as packages. These keys can be inherited by defining them in the member package. So we can define, so some of this actually makes a lot of sense to me. Like the license specify that at the root, inherit it in each of the crates. That if we're using like a virtual, like I said, at what point does it stop being a virtual workspace and start being? Does it actually say? But without a, okay, so if you add a package section, then it stops being a virtual workspace and it becomes a real workspace. I guess so. But like the license definitely makes sense to me. Specify, I mean, I guess there's going to be situations where you have different licenses in the same repository. But I would say for the vast majority, likely it's going to be one license for the, like it's going to be the same license for everything within that repository. And something like categories and keywords, those potentially. In addition is probably going to definitely make sense. Probably, definitely. I would be very surprised if they had multiple editions in the same repository. It feels like that would make sense to keep that all the same edition as far as maintenance goes. Editions come out every 3 years, I think it is, and they're like opt-in major versions almost. So rather than bumping the actual major version, they have some like opt-in features that you can get by upgrading to the latest edition. So it's like major bump light. You can bump up to the more recent version, but you're not like necessarily excluding others from, or requiring others to do the same. That's probably the best way to describe it. So we can effectively describe all of these and put these in the workspace.package. So what I think we then need to be looking out for as far as covector is concerned is if we have a root Cargo.toml and there is a workspace.package.version, that is where we would need to start paying attention. I think we would still require the user to point to this file specifically, the root Cargo.toml, that is. And then the question becomes, do we make, if we're doing that, do we have a changelog for each? I kind of think you don't. I think if you have a workspace.package version number. You have a changelog for that. And if you have any crates that are using that number, their changelog is that crate is gonna have a version bump every time the root one bumps, in which case the changelog should effectively be the same. So I don't think we have a separate changelog in that case. I think we have a changelog per version, per Cargo.toml that has a version specified. So you could have, I think you could potentially have, say, 4 crates, 2 of them take from the root workspace.package version number and 2 of them don't. You'd have one changelog at the root that also covers those first 2 packages, and then we'd have a separate changelog for each of the others that specify their own version number. I think so. So let's give this a high-level summary here. The Cargo.toml has the concept of a workspace. A workspace is something that you use in a monorepo. You have effectively 2 types of workspaces, a virtual or a non-virtual. A virtual would be where we are specifically just specifying the members, and each package defines its own metadata. Within that metadata, there's the package key, and it has a list of keys that are supported. One of which is the version, and a few of the others are like the name, and I guess not the name. The name, the description, the license. Those can also be inherited from the root. So each crate can specify their own, or in the case of a just normal workspace, you can inherit it from the root. So the root can define a version, workspace version, and the package can then inherit it. We need a good example of this. Yep. So in the case of a workspace specifying, in the case of a root having a workspace, it can specify some metadata at the root, and the crates themselves can then opt into using that exact same data. So I think we kind of understand what's going on here, and I think we have an idea of how we want to deal with this. I think we go for a stretch goal now. We haven't actually spent too much time on this. Let's try throwing in a couple fixtures and writing some tests for covector real quick. So we're going to switch from the Rust side of things a little bit to JavaScript, because that is what covector is written in. Covector is partly written, I know people have talked about rewriting Rust a few times, but I don't really see the value in it, because the type safety and the compiler helping you in Rust is real nice. But you need to create a binary, and the binary needs to be generally specific to operating systems. Covector is generally something that's run always in CI and sometimes locally. So like it might make sense to have a Rust binary that helps you create the markdown files. I could see some sensibilities there. That GitHub action though, and other ways to run it, you'd end up having to create a binary for every operating system that you potentially want to support, which is not terribly easy to scale. And also in GitHub Actions, you can commit the dist directory to the repository, and now when you run that GitHub action, it's just going to download that directly, which means that your CI runs using this action are going to take seconds instead of having to download, instead of having to like compile a binary. We could potentially commit 3, 4, 5 binaries, however many we need to support all of the different operating systems. Because remember, we've got Windows, Linux, Mac, but also potentially multiple flavors of Linux. I don't think that'll be an issue here, but potential. And there's also 2 types of Macs now. We got ARM and Intel based. We can potentially create a single binary that works on both, but also something to consider. So that being said, it's real nice just to have one dist. I guess for the most part, it's going to be this index.js. That's for the most part, that's the thing that we care about here. This dist is on Windows right now. What we have written here actually does work on Windows, but what we have pushed up theoretically is only going to work on Linux and Mac. This killer.exe is a way to gracefully shut down a process on Windows. But we don't have it committed, so technically it will work on Windows, but it's going to just like, if anything is long running and it's not shutting down, we're not going to be able to gracefully shut it down, which shouldn't really be an issue, but it's something to keep in the back of our head. So for the most part, what we're doing is we're able to support all of the operating systems with generally a small amount of code that's actually committed to the repo. And on top of that, the parsing of files and Markdown in particular has had a lot of support in JavaScript and TypeScript. So, long story short, I think for the foreseeable future, we'll stick around with it's TypeScript actually. But maybe at some point it'll make sense to write pieces or all of it in Rust. So we want to look at specifically the version. When we are importing and looking at I think we're all the way up here. Yep. Well, we're looking at the different types of packages. We have a chunk for processing toml files. And we're using toml.parse. And I've been slowly like rewriting it from JavaScript to TypeScript. And there are still a couple wait a minute, I think I fixed that one. Git pull. Yep, I definitely have it pulled on this computer for a little bit. That looks much better. Okay. There we go. So when we grab the package.toml, we're both recording or keeping track of the actual toml or the data that's in that toml itself, but also we're pulling out the version number that we care about. It is specifically looking in the package directory though, or in the package key. So I think what we need to do to support this is we need to, if this doesn't exist, we need to fall back to the workspace. and see if there's a workspace. Workspace.package.version. Now we want to consider if they're pointing at I should say this one. If we're pointing at the root, or if we're pointing at this one. So I want to double check and see how this is parsing. I don't know how the TOML parser that we have is going to deal with that. If it is actually going to be package.version.workspace. Need a bit of a drink, I guess. If in our config we were pointing at the root, we would not see a version under this would basically become, this would be undefined. We're not going to have a package version. And I think in that case, then we fall back to check to see if workspace.package.version is set. And in this case, depending on how this comes out, we're just getting a TOML, so we don't know. We don't currently have a way to specify if we're pointing to a crate Cargo.toml or if we're pointing to like a root workspace Cargo.toml. I don't know if we need that though. If we check for package.version and it just doesn't exist, depending on how this comes out first, we can just fall back. I'm gonna bump this up just a little bit here. So I think it's potentially going to be sufficient to, in here, say, basically fall back, grab that version on a fallback and pull it from the workspace if it's available. Now that's the read side of it. The write side of it, is that up here too? Let's see. Gotta parse. Load. Read, write package file. So we're calling save file. Write prefile, write change file, load, read. Is save coming from? Ah, there it is. Okay, so we're just straight up doing the content off of the file. I wonder if content can actually come back as empty. I want to double check that. Right, read, get, set. I suspect I probably want to switch this around a little bit. So right now it's setting a version and it's setting it in the parsed version of the package. So we completely dependent on the type of the file and the file structure. We're taking it and we're parsing it in a JSON, and within covector we're operating on everything within it, like in memory we're operating in JSON, and then at the end of it we are taking that JSON and converting it back, which works. But the problem is we need to be able to round trip it without being destructive. So if we parse a TOML into JSON, we now work on JSON, and if we save it back to TOML, we want to have the only thing that changed in that TOML file be like the version number. So if the only thing we're changing is the version, we want like a 2-character change. But the problem is some of these operations are actually destructive, where I think right now all of our comments actually get stripped out of the TOML. So I think this function is actually going to be changing potentially in the near term here. I know that's something that I would want to deal with soon. And you can see here, like, TypeScript also struggles with a bunch of this nested, this kind of stuff. Set package. So this is like, if we, in this case, we're actually setting the version. This ends up getting even more complicated because we're not only saving the version, we are also having to consider if it's in the workspace or if it's in the package. So here I'm specifically checking, hey, is it in the package or is it in, and you know, like, I'm expecting it to be there. I suppose it's actually not going to be as bad as I'm initially thinking here, because we can add another whoop, didn't mean to press that. We can add another section here that basically says that. I do wanna change that though. Tickle in my throat here. I think that'll be fine. I think that'll be fine for now. And then we just need to consider when we're reading it. I was going to set up our fixtures first and write our tests. But honestly, like, this is not, I didn't expect this change to be awful. But it's actually less painful than I was even expecting. So we can do something like this, version. And we can then fall back to, how do we want to do that? So if we have that, let's do parse.toml.package.version. Otherwise, parsed toml.workspace.package.version. Yes. And I do have a check here. So maybe we actually expand that a little bit. So I'm saying if we don't have a version set, so I'm checking here specifically for the version, and then throwing an error if it doesn't exist. So I think what we can actually do is say let version, and then we will say if version is not defined, not a valid version. And we can say here, say package version is Ugh. Hopefully I'm not coming down with something. That would be no bueno. So we can do, I think we can do kind of two things here. Let's throw. So we can say if it's not valid, throw. Package version is not valid. Actually, I want to do this first. So we can say package version is not set. So it's going to be undefined. Cannot redeclare block scope variable. Yeah, okay, that's fine because we have it here. And now what we're going to do is we're going to say if that and it is a string, I'm not going to check validity right now. I'm just going to make sure that we have a string in here. And we're going to say version equals this. And we're going to say else if and do the same except for the workspace. So if neither of those are true, if we don't have it set at the package level, not specifically like in a crate, but instead we have it set at the workspace and we're pointing at a workspace root, then we will say parse.toml.workspace.package.version workspace. Then we should be able to set this. And now we will throw an error if it's either not set or it's not valid. Let's see. So package version is, I guess we just say the file path is not set in this file.path. And if we don't have a valid version, we say package version is not valid in this. I think that's going to help us out enough. And we probably want to also write tests to check those error cases. And now let's write a couple of tests here, and I think that's where we're gonna end up calling it after we're done writing the tests. We have a few like styles or groups of fixtures, I would say, and I've used like dot notation to help separate them. Integration would be more for like we have change files alongside like Cargo.tomls. This is specifically for parsing and writing, so I don't think we need that at all. I think in our test we can probably just have the packages. This is probably going to be in toml parse. So this here specifically is a test for parsing, but not the writing. Do we have tests for writing? So this is general. Maybe I do a toml.write or toml-write. I think I'm actually going to rename that. I don't have any writing. Interesting. I guess I check all the writes at the root. So I have kind of, in covector we set up basically like 2 levels of tests, which There's probably things I could do better, and with more time we could improve it. I'm generally not a fan of snapshots if you're ignoring them. And I would say most cases that's what happens, is somebody does a snapshot test, and when they change something, the snapshot changes, they go, oh, okay, I changed something, the snapshot should change. I'm just going to say it's cool. They don't actually review what that change in the snapshot is. And snapshots can be very, very chatty, and I don't think it encourages that. If you're using the snapshots and actually inspecting what's changed, there is some value there, I think. And that's how we end up doing it in covector. We're doing sort of like two levels. We've got, I think of them more like unit tests. Some of them are very much like a unit test. Like we're doing one function, we're checking that the function is returning a thing. Some of them are a little bit more integration-y, but at the root we have like real, I guess not the root, the main package. We get into like more like real actual integration type tests where I'm giving it a directory and running the test, or running like the CLI against that directory. So it is pretty much as close as you can get to, real use case. And in there, we are using some snapshots, of which I am snapshotting, I think, mostly the console.log. So there's two things that I end up checking. We check that the file has changed in the way we expect it to have it changed. So if we run a covector version, we expect that version number to be bumped with a patch bump. So we're checking effectively two things here. We are reading the file again, making sure that version number has changed to what we expect it to be. But then we're also inspecting the output. So we're making sure that the console log output hasn't changed in a way that wouldn't make sense. There's less like quote unquote breaking changes that would go into the logs that are coming out. But if somebody accidentally leaves a console.log in there, then things get a lot more chatty and the output is less valuable. So we want to prevent that. But then also we want to make sure that those logs that are coming out are clear, kind of out of context. So like when I'm writing an error message, what we just did here, and what I had before probably was not terribly useful. And that's a more recent change. I don't know if that's actually published yet. I think that was actually part of the last PR that I did. So even as I say this, it's, nothing's perfect by any means. But I want to make sure that when it says package version is not set, when I have the context here and I'm writing that error message, I understand that that package version that's not set is the thing that I'm talking about here. When you just see a log or an error message that comes out, sometimes you'll get a decent stack trace. Not always, depending on context. If you're just doing like a console.warn, you got to make sure that like what's coming out is going to be understandable to somebody without context of where that error is being thrown. So that's kind of the two things that I'm thinking about when I'm writing these tests, especially like at the real high level integration type. Everything has gone through and changed like I expected it to, but also the logs are actually going to be helpful. I think in this case though, for the most part, we are changing just these. And I think I could probably just adjust this. I think I am going to say we're going to change this. We're going to rename it and just call it Part.toml. Of course, that's going to do that. I don't know why VS Code does this. I'm pretty sure it's some extension or something like that. That actually wasn't too bad, but sometimes it'll take forever to run. I don't know if it's running pretty or something in the background or whatnot, but like renames and like sometimes saves just take so long. And it hasn't been painful enough that I've actually like cared about dealing with it. It's starting to get to that point though. So we're gonna do a describe for the parses, and we're gonna add in another one that does the writes. TOML writes. And I think this is actually gonna make it obvious. We're gonna do two things here. I mentioned that I'm pretty sure this doesn't round trip and it actually strips out the comments. We're gonna want to write a test for that, and I want to eventually fix it so we're being less destructive. And I think it's potentially we read, but then our writes back. We read, we get everything into JSON and into a JavaScript object. We operate on everything, get the values that we want to change, and then we do more of a like a regex type method to write back, which is going to take a little bit more effort and test it to make sure we're doing it correctly. But we can do it, we can write it, and then we can parse it again just to make sure that we didn't really like royally goof something up. I think in that case though, we're not going to be dependent on our parser to be non-destructive, which historically hasn't always been the case. And part of it too is there's different versions of TOML, there's different versions of YAML. If we're being less destructive about our writes, I think that's going to provide better compatibility between the different versions, because it's not only different versions, but it's different implementations. Like languages will either, if it's in like their standard parsing library, they will be potentially implemented differently than other languages. There was actually a good article, I don't know if I'll be able to pull it up. I might throw it in a comment below about sort of the, I don't know if atrocities is the right word, but there are gotchas when you're writing YAML, most of which I think at this point are around how the YAML is interpreting and parsing something. And I think it actually mentions it in the article, but I've definitely found myself doing the same, that if I want something to be a string, I'm quoting it. And you end up basically having, I guess, two data types that I mostly end up working with when I'm writing my YAML is booleans and strings. So I just quote everything. And for the most part, that's gonna remove all the gotchas, because most of the gotchas are with like how is parsing something and like pulling out a date or what have you. So unless I'm very clear on what a specific syntax is going to return, like a specific data type, I'm pretty much just quoting everything just to be safe. So anyways, all that being said, TOML, we want to both care about how it's parsing it, but also care about how it's writing it. So I am going to just kind of write a placeholder here for the moment. Say expect true to be true, and that should, we are writing within the scope of Effection. Effection is a library that is written using generators. And there's some ability to do parallel processing in a way that promises are sort of falling short. Promises, async await, what have you. But generators tend to be much more low level, and they haven't quite seen the the effort put into them like promises have. But with affection, it feels very much like writing with promises, but with all the power. Doing parallel processing versus not, and being able to like tear down based off of scopes. It's really nice. But there are considerations when we start getting into libraries like Jest that expect anything async to be literally written using async or promises. So in this case, we have a special helper from affection called Jest, or called affection, add affection/Jest, which allows you to write generators, and that generator is run within a specific affection scope. So let's do another test here. We're gonna have with file specified by deriving. What's the difference between these? Okay, so package config. Yep. So here we're specifying Rust, and we're just like letting it figure it out. Here we're saying, hey, use this. We're actually gonna add in, this is starting to get a little bit deeply nested here, but it parses single Rust. Yep, no. Describe is still just a function. And then I'm going to do this, say Workspace. .toml parses single Rust create. .toml parses Rust Workspace. So now what we can do is we can add in a fixture, and we'll pull that in and we'll start running some tests. So right now we're doing Rust's package, Rust single, package, Rust single here. I guess we've got two types of Rust workspaces. We've got a we've got like one with inheritance and one without. What does this look like? I think maybe I pull in this Rust multi. And we say Rust workspace, and we say with inherit with version inheritance. Did I spell that right? With and without? I think with and without probably makes the most sense. So our expectation here is that we are going to be doing a cargo folder. It's going to just figure it out. Read package file. So we're specifically giving it a package file in this case. We don't have anything at the root. This is a virtual workspace. I think I'm actually gonna put that here. Package.rust multi is a virtual workspace. And we can link specifically to virtual workspace here. So we're going to say cargo file package A. this parse read, I think, is a higher level thing that calls the parse. Read package file. So it is doing the parse. So what we should be able to get back is, yeah, we should be able to get the version. Yeah. So I'm gonna check a couple things. We're gonna read the first one. And I think we're actually gonna have to update this. What is this called? Let's see if I named them the same. We are looking still for a Cargo.toml in that folder, except we have a join in here. No, we don't. Import path from path. Because we do need to adjust this slightly. Path.join. So we have a cargo folder and we want to join it with it's in a subfolder, which is package-a. Nickname is for the parsing. I don't think we actually care about the nickname. I guess we do care about the nickname. Okay. Well, let's write these first. So name, that should all be the same, and version should be 5. Okay. And then here we are going to change this to say B, and we will double check that our package B is not terribly different. The version is slightly different. 8, and this needs to be B. Okay, so in this case, we're setting the nickname. It's the same thing as the name. Should work fine for this situation. All right, we are gonna only run this, and we are gonna say MPMI, because I don't think I've installed recently. Also, updated version of Node. Where? Come on. It is licking my green screen. I don't know why she does that. All right. So if we do. What are you doing? Coming up? Want the attention, or are you just like looking at it? We're gonna run npm run test, and we want to do. I want to filter on just. What are we in? Files, I think. Come here. Ugh. So this is going to run all of the files, or all the test files in files. but we actually don't need all of these. So I think I'm going to say file/test/toml, because we just want to run the toml for right now. We'll end up running the whole test suite because I think the integration tests might change slightly. Maybe. All right. We expected B, received A. Okay. Oh, yep. You know what? Because we didn't change this. And we can do, I think we can do dash watch on this. All right. So this should pass. This is basically existing. Yep, existing functionality. So now we can do the same, except what we're going to do is stop. Yeah. I don't get why she likes to lick that so much. What can you do? I'm gonna go ahead and copy this, and we'll tweak it slightly, and we're also gonna copy that same fixture, and we will tweak that slightly so that it go. So we have a Rust multi without workspace inheritance, so virtual workspace, and we are going to copy that and paste it, and we are going to say Rust multi inheritance. So now what we can say here is we've got workspace, and we can also specify packages. And that would look something like this. So we've got members and we got workspace. Then we got also a workspace.package. Ah. I say stop, and she comes over and says, "Oh, hi, you're talking to me." Yeah, it's fine. So we've got an version in here, 1, 2, 3, and now we should be able to say here. So we should be able to say version.workspace equals true. We've got package, and it is actually just under the package. So we can say version workspace. It's true. And that I feel like I saw something about this on is it Mastodon maybe, that this is technically valid toml, but it's not as far as this VS Code plugin is concerned. I think I'm fine with this. We're gonna copy and paste this, so all those should be fine. Just save without formatting. That those errors were saying like that's not valid crate, which makes sense. It's not. Do version description. Authors equals this. Boop. All right, so in this case, we have a package A, and that is inheriting, We have a package B, and that's currently not. I think I'm okay with that. So now, if we go back to our tests, we say with version inheritance, package A. We do have to pull in from the new fixture here. So inheritance. We're still in this. We copied from the other one, so we're still reading A and B. The names should be the same. This is going to not be defined. But instead, we're going to have, this is going to be 1, 2, 3, and package.workspace.package.name should be this. Let's see what our tests look like here. I think she finally gave up. She's very determined. Okay. We get with version inheritance is failing. It is throwing on package version is not set in. So remember what I was saying before about double checking to make sure the error messages made sense? That's not helpful. What else could we put in there then? Why are you complaining about that? Is this what TypeScript am I using? Auto detect. I don't know why that's being squiggly, but I'm not gonna worry about it for right now. So we have a file. File is a partial of file, which is, what do we got? What are we working with here? Is there something else that we can? File name. What does that look like? Oh. Yes, you. What? Stop. Very much appreciated. Okay, well that worked even less. So file name, just file name extension. Path would be the full thing to it. And content. I guess we do have the parsed. So we could say the parsed toml dot name. Can we guarantee that the name is going to be there? So if it's a toml, we're parsing the content. I think we could probably rely on that. Determining test suite to run. Undefined. Guess that makes sense because it'll actually be package.name. But see, like we run into the same situation too, where we need to consider which one are we. which one are we thinking about here? What does this parse package look like? We're calling it from read package file. And we are using a load file. So load file is going to be giving us that object. So load file, we could potentially say, I think that is also in here. We are setting the content, the path, the file name, and the extension. We are doing a little bit of path manipulation here. And we're taking the current working directory plus the file. I suppose we can say full path. Should we say like full path? Does that make sense? We are doing some stuff where we are splitting and joining on here in this relative. We're basically end up I guess we say relative path maybe. Then it might actually be fine. We are doing it relative to the CWD. I think we're actually good with that. Because we're, in this case, it's erring on the file that's in the root. So in Cargo.toml actually makes sense. But I think I just need to prepend it with a // to make it clear that it is literally pointing at the Cargo.toml in the root, not just a generic Cargo.toml. Set in file.path. Because it's literally that. And I think that was where my confusion was coming from. I thought it didn't actually have the full path relative to where you're running this. It does. So that it's still going to error. It's still not going to work, but we should have / cargo.toml. And yeah, and I think that makes it much clearer because that should have the full path if we're like looking at another file that is not sitting at the root. So what is our actual error? Package version is not set. So when we're parsing, we are getting to this. So we don't have a version specified. So if we just straight up log out the parsed toml, can't remember if I'm in some of these, and this becomes a little bit of an annoyance because in some of these integration tests, we don't have a logger set up. We're just doing a console.log, and do want to fix that. Logger would be real nice, but just haven't had time. Then what ends up being an issue is when we're capturing those logs, they don't end up getting written out to the terminal, which is nice when you're running the test, but when you're trying to like figure out what's going wrong, you can't just throw a console.log in there. Well, we don't actually have that. We're not just hiding them, so we're good for the moment. Okay, this actually makes sense. Does it make sense? We are throwing an error at line 70 for Package version is not set in Cargo.toml. We are reading that file. I wonder if it's actually airing out on this one. No, they should both work. Describe.only. Okay, so it's also running it on this other one too. That's why we're getting multiple logs. I don't know if I need that other only in there. So we were getting 3 logs. These I think are from the previous run. This is the one that we care about, of which it has a package and then that's where it's not actually picking up the thing that we care about. So that's where we're getting the error. So we are looking for we're looking in package.version. That doesn't exist because it's set to workspace true. So that's actually a good error. I forgot to take this out. We want to look at the root one. I don't want to look at that one anymore. I care only about the root. So that error was saying we were pointing at package A and it doesn't actually have a version specified. Can we adjust that error message slightly? That's what we were getting. Not set, right? Yeah, not set. Yeah, that makes sense. But actually, that being said, because it's all relative to CWD. When I'm writing the test, I'm setting the CWD as that cargo folder. Can I do package -a and just not change my CWD? I'm going to take this off for the moment. I want to make sure that I'm not accidentally getting confused with this. But if we do this, is it going to set the CWD there and we then point here? We'll still get an error. I think it's going to change the error message though, because we were originally getting package version not valid after this most recent change. So now we should, there we go, okay. So that makes sense. So that I think is going to be a good error message. We just wrote our inputs just a little bit different than we normally do the main setup. So we're getting package version not set. That makes sense because we want to be pointing at the root. The root one is going to be this. And we are not. Okay, so now we're just doing the one with version inheritance and saying package version is not valid. And we are getting workspace members package. Okay, workspace package version. Workspace package version. Workspace package version. Parsing.toml workspace package version. And it's a string. That seems like it makes sense. But it's saying that it is not valid. Oh. There we go. We are figuring out what the version is. Then once we figure that out, we are making sure if it's undefined, throw the error. But it is, if it is defined and we're getting something back, we want to check that it's valid. And I was not checking the value that we were setting, but rather otherwise. Okay, so that makes sense. Now, this is not going to be true because we are only looking at the root. So it's not going to be that value. It is going to be a root which is not set. We do want this to be undefined. What did I do for the name? So I don't have a name. So it's not worth checking that. I do want to make sure that it is. Is this valuable? Checking that it's undefined? I don't think it actually is. I only really care about the version number here. I want to make sure that the version is set there, but I also want to make sure that we have I mean they should both be true, but it should be package workspace dot package dot version is going to be this. Both of these should be true. We should be pulling it out of this. We're parsing it, and then we should be pulling out of this, and we should be setting it here. And that's going to get us our read. There we go. And then this is going to be effectively the same as the other one. But we just want to make sure that in the context of this, I guess, partial workspace inheritance, one of them is, one of them isn't. Just want to make sure that we are also considering this case. Okay, so that looks fine. We're gonna pull these onlys out so everything can run, just to make sure we are getting a full test. And then here we're gonna say write, and I'm gonna grab this whole thing here because we want to make sure that it also writes to the workspace. And this is going to be a little bit different test. Because this is specifically reading. So if we change the version number, we want to then be able to write it back. So there's going to, in our scripts, we've got a read case. And then we've got a write package file. And this takes a package file and a CWD. So we can, using our fixtures, we can actually, this is like a temporary directory. So it's copying that fixture, putting it in a temporary directory. So we can actually do file system changes on it and see that reflected in our tests, which is real handy. So we'll go ahead and just focus on this one for the moment. We're gonna copy over Rust multi. I guess I could leave that there. We are going to, I don't really care if that version is there, because we should be checking it in the parse. But what I am going to do is I'm going to change the version. I don't think I actually technically care about any of the other fields. We do save like broken down versions of this. Those don't think they actually matter though. When we write the file though, we are writing it. Okay, so I do have to do set package file version. That's going to set the version, which should pick up the thing that we also checked here. So we're gonna do, it's gonna be something like that. Whoop. Something like that. Yep, import it, please. Okay, so we need package version property dep. So package is the package file. That'll be the cargo that. Then we need the version, and that's going to be 4, 5, 6. And then we need the property, and that is going to be version. And I don't think we need to define the deps. So this should basically we're modifying that value in memory, and now we should be able to do a yield right, I believe, or save file. Is it save file? File and CWD. And this. Ah, that's not an object. I guess I didn't do this one as an object. Which is fine. Okay, so do we care about this? If we are just changing this? I guess I don't. We're gonna do this, and then we're gonna say expect. I need to like reread it again. Package cargo file modified. And then we're gonna end up having basically a check here. Let's just straight up check the version. We should be able to say that the version has changed. And this should be 456. 4.5.6. Wow. Too aggressive on the deletes. Okay. Did a bunch of errors. TypeScript. Type package file is not assignable to type operation any. I think what we're doing is we are trying to save a file and it's expecting a file, but we are giving it a, yeah, this isn't any. When we read a package, we are doing an operation, and we should be returning read package file. Yeah, we should be returning a package file, which I think is going to be different than file. We are actually going to do this. Gonna help me out, are you? Affection. Import operation from affection. Operation is the scope or the wrapper around the generators, and that's what ends up handling yeah, see in here now this is starting to help us out a little bit here. Package operation package file is not assignable to type package file. So actually the operation has been completed because I yielded, so I actually don't need this. So this should be a package file, and now that's actually complaining because it's saying, hey, no bueno. So if we do this, I think that's what it's expecting. So we can say expect this to be defined. Go away, TypeScript. I think we can use, there's an assert package or something, assert TS, that I think would potentially make this cleaner. But like, by the time we get here, this will have failed if it's not defined. So like we know it's defined, so it should be fine. Type package file is not assignable to type operation any. So what? So that's expecting an operation file. So how are we writing? Save file, load file. Oh, did I do? There's a write package file, isn't there? Config file, test, write to prefile, set, get, write. I called the wrong thing, which makes some sense. And we will remove this and that. Okay. So we expected one argument, but we got two. Write package file expects this. Was I looking at this before? And then I just used the wrong thing. I feel like I package file. There we go. Package file is not assignable to type operation ID. Is it really like complaining about this? No? Is set package file version. What is that returning? Get, set. This does return a package file. Now if we do this, cargo file package, cargo file memory package A. Now we write it. That should be now. We modify it. We read it into memory. We take that in memory. We modify it and return. So now we have like that modified thing in memory. Then we write it out. Now we should be able to read it again and check that the version has changed. Is it not like in there, right? Test.only. I've not seen this before. Call signature return types, generator, package file. They're incompatible. I mean, we're literally doing the same up here, aren't we? It functions are. We're copying a thing, then we're yielding, and we're doing some expecs. It's really just not like this. Interesting. So what's different about this set package file version? Not a very clear error, unfortunately. But it makes sense now that I see what I did wrong. Okay, so without version inheritance appears to work. Now, if we do the same except with version inheritance, we can, let's just copy some of this. I'm actually just going to paste it over the top and we'll just modify it in place. We are reading, we still only care about package A. In this case though, we're going to be, I think I'm actually gonna write file package. I'm gonna change it to be this because this is in reality more so how it's actually used. But here we are looking at the one in the root. We are setting this. We are writing it back out. But this is not being written anymore to this. It is instead in the root. So I think this should work. First shot? Well, first shot almost. Okay, we have without is not working now. Okay. So CWD here, we're setting the file to be this. So CWD here, actually in both of these cases again is going to be this. And we're going to say package A that. Hopefully this gives it to us. Yay, there we go. Okay. We have some tests that pass. Let's run this whole thing. We'll run the whole suite. There might be some tweaks in output. I don't think so. Let's give it a quick try. We'll give it a quick shot. Either way, though, I think that's probably what we're going to call it. Even if stuff doesn't pass here, got a meeting to run off to. But we went over workspace inheritance in the Cargo.toml. I think we understand the difference now between virtual and non-virtual or normal workspaces. Or maybe a better way to say it is we understand what designates a workspace as virtual. Been very lurky. Nice. Hey, Chris. So there's a couple ways that we can actually configure our workspace and our crates, and we can define some of that at the root and have the crates within it inherit it. And I don't think it's specifically it doesn't appear that it's specifically for non-virtual workspaces or real workspaces. Oh no, actually it is. Yeah, it is. because you have to specify a workspace.table and a workspace, or excuse me, a workspace.package. A workspace.package is the thing that designates it as the only way to make a virtual workspace is to not have workspace.package defined. Okay. Actually, so this is the other thing. With snapshots, it is very specific on what the output looks like. I need to run this in Bash. Time we got. We can run it in Bash real quick. So my tests and my snapshots expect to be run in Bash. Because this right here is new shell. New shell, when we're the way that I'm testing and outputting some of my code, it actually ends up putting quotes around it, which is fine. I mean, from a output standpoint, like I think the output is still fine. Like it runs fine in new shell. It's just that I am comparing output that's expecting it to be a single or to be a word without any quotes around it. But new shell ends up basically putting quotes around all this stuff, which is pretty much where you're seeing all these different errors. So I think if we did everything good and it's running in Bash, everything should pretty much pass. Some of these things take a while to run, especially on Windows, and it gets even worse when I'm streaming. We blow out some of the timeouts on Just, and I think part of it is the reason it takes so much time is because we're actually we're using this library called fixtures, which honestly hasn't been updated in a while, but it's not doing much. You can define a fixture and it's copying it into a temp directory for you, and you can do the exact same file operations on that, on those files. So we're effectively not mocking anything in these tests, which I think in this specific case is really useful. Yeah, it looks like all these are just exceeding timeouts. What is this though? Expected this. Yeah, okay. Yeah, I think it's all like timeout pipe stuff, which is fine. I mean, when we push it up, it should work fine. And I think the bulk of this, like these times are much larger than normal. Probably mostly due to streaming. So I think we'll call it good. The tests specifically for what we were doing pass. Here, let's just run the without watch. And we should now be able to support the workspace inheritance just fine. Yeah. Okay, I was safe that failed. Cool. I think we can call it good. We'll get this up. We can probably push out a new version in covector to support this. I don't know how I missed this. I feel like I've been keeping up to date mostly, but like this was like 1.64. Is that what I wrote in the description? We're on what, 1.67 or something? Guess it happens. Get busy. But I think we're good to go, and we got a new thing that we can play with when we're setting up workspaces in our Rust projects. So we'll leave it at that. Thanks for stopping on by, everybody. Still not used to the Tuesday. I almost said happy Friday. We got a week ahead of us. And actually, part of switching the stream to Tuesday, the benefit of that is it makes it a little bit easier to give me a few more days to edit video. So I got a short from last week out, which took a lot longer than I was hoping. I very much will look to make that process faster, but yeah, I'm gonna try to do at least a short or two like a clip from each of these streams, which I think will be nice for folks that don't want to aren't able to make the time to watch a few hours stream every week. And next up, videos. I've got a couple scripts that I'm in the process of writing, so I'm not going to promise anything. They'll come out when they come out. Next time, though, I think we're going to play around with Tauri Mobile. There is a V2, I think alpha still, of Tauri that supports Android and iOS. And I think we got to button up the last bits of it, but I think I'm going to get Jonas on the stream, and we're going to pair up, and we're going to see if we can poke some things and make some things happen on mobile. Next week, same time, same place. Have a good rest of the week. Bye.